Hello, in this video let's discuss third question of today's biweekly contest. You are given an array of positive integers and k. You can perform at most k operations and you can choose one element and double its value. Each element can be doubled at most once. Your task is to return the maximum score that can be achieved where score is defined as product of length and GCD of the subarray. And the constraints are length is up to 1500 and k less than or equal to n and value is up to 1 in n. So obviously n is less than or equal to 1500, so n square is possible. So what we can do, for every starting I, we can traverse all the subarrays and we can try to find the answer because the length is fixed, right? For example, we are at first index and we are starting from 0th index. For this, the length is 1, so we have to find the maximum GCD possible for this one. And similarly, we are going for this one as well. The length is 2 fixed, but we want the maximum GCD value. Similarly for all. So in this way, we try to keep one constant. We cannot try to dynamically change both. So if we try to fix the length, then we can try to find the maximum possible GCD. Then fixing GCD, the fixing length is very easy. So we'll traverse every subarray and we'll try to find the maximum value for fixed length array from every index. And what can be the maximum GCD possible? We are doubling the values at most once, right? So obviously the GCD can multiply by 2 because the most simplest assumption is the value is 2 and k is equal to 1. So obviously we'll double it. So maximum GCD possible is 4. So obviously the answer can only be twice the maximum. For simplicity, assume only 2 power values because we are dealing with multiplication of 2. So what is the simple thing that we can remember? So it is just 2 power values. So these are the most simplest values that we can think of. There are 2, 1, 2, 3, 4, 5, 6, 7. So 2 7s, 1 4 and 1 8. If k is equal to 1, what is the answer possible? What is the new maximum GCD? If k is equal to 1, we can try to replace these 2 by 4. Even now the GCD is 2 itself because we have some least values 2. Because we have value 2 and any number which is greater than 2 and which is 2 power, obviously the GCD will be 2 itself. If the least value is 4 and any other values, obviously the least is 4, the least 2 power value is 4, and obviously everyone will be greater than or equal to 4. It will be 8 or 16 or anything. Now the GCD is 4, but here we have still 2's, so answer is 2 for k is equal to 1 and it is 2 for k is equal to 6 as well, because even if we have to replace all 2's except 1, if I have only 1 2, even then the GCD is 2 itself, right? So for k is equal to 1 to 6, the GCD is 2 itself. When k greater than or equal to 7, then the GCD will be 2 into old, which is 4. Originally GCD is 2. So if we try to increase the least value, because the least value is 2 here, so if we leave at least 1 2, the GCD will not be changed. If we change every value, only then the GCD will be doubled. So the first observation is, it is dependent on the least 2 power value if all are 2 power values itself, because we assume that this is the simplest one. But what if we have non-2 power values also? So let's take 4, 6, 8, 12. So 6 is not 2 power and 12 is also not 2 power. So let's take this and let's assume k is equal to 1. What is the maximum GCD possible now? In the before case, we are sure that all are 2 power values, right? So the least GCD will be least 2 there in the array, or if k is equal to greater than or equal to frequency, then 2 into least will be the answer. But now there are non-2 power values also. So even now we will try to double the least one. So if we try to double the 4, it will be 8. The new array will be 8 6 8 1. And if we try to suppose, for example, let's try to double this, it will be 4 12 8 12. The GCD of this is 2 and GCD of this is 4. So here we can clearly observe that multiplying the 2 with least value is not correct, because in this example we can see it is 2, but the value which we can get when we double 6 is 4, which is greater than above 1. So doubling the least value is obviously not the correct answer always. It is only correct in the previous case. So how to tackle this one now? It's not the least value that is guaranteed. So what is the maximum new GCD? It can be double of the old one. When GCD will double, we discussed that when the least 2 power will be same, like all the 2 powers must be replaced, all the old 2 powers. So now it is 4 and 6. So 4 is equal to 2 into 2, 6 is equal to 23. What is the GCD? It is 2 old originally. And now let's try to double the 4. What will be new values? It will be 2 into 2 into 2 and it will be 2 into 3. And now what is the GCD? GCD is 2 itself, because we have only 1 2 and 3 2. So obviously the minimum of this will be, because let's say we have 2 power 4 and we have 2 power 20. So what is the GCD? It will be the least value of these both. If we have 2 power 2 and 2 power 4, then what will be GCD? It will be simply minimum of both, which will be 2. Similarly, we have 2 power 1, 2 power 3. So GCD is 1. So it will be 2 power 1, 2. And if you are trying to double 6, It is 2 into 2 because we are not changing this, and now we are multiplying this. Now it will be 2 into 2 power 2. It is 2 power 2. So now the minimum of these both is 2. So the answer is 2 power 2, which is 4. So we observe that from the example that doubling the least value is not important. Doubling the least value with least 2 power is important, because here we are doubling the value with the least 2 power. But this is not the less one, right? 4 is less, but it is beneficial to multiply with the 1 with less 2 power, which is this 6 here. So find the maximum 2 power value of every value. So what is that? For example, we have 18. So what is the 2 power maximum value into some other primes? So it will be divided by 2. So only once. So 2 power 1 into 9. And we cannot reduce 9 further in powers of 2, so let's leave it. And for 24, what is the maximum value? It is 2 into power 3 into 3. So we'll reduce the value by 2 till it is divisible by 2. And we'll increase the TP of it. TP is the maximum 2 power value of the present index. So after this, what we'll get? We will get the 2 power maximum value that is possible for every value in the given array. And when we are at Subarray, because we discussed that we are traveling all the Subarrays and we are at I. And for example, we are at the present index j, and now the length is fixed j minus 1 plus 1, j minus I plus 1. So what is the maximum GCD possible? From the previous examples, we got that the GCD can be maximum of the old GCD. What is the old GCD? So simply take a present GCD, which will be GCD of the present and V of I. So this is the normal GCD without any k modifications. And now we discussed that we have to double the value with least 2 power frequency. So we have to track what is the least 2 power value and what is its frequency. Because in the previous example here, we got that least is 2 and this is 6. So GCD will be this if k is less than this. K is less than or equal to this, and when k greater than or equal to this, greater to 7, only then the GCD can be doubled. So we want the least 2 power value and the frequency of the least 2 power value as well. So maintain this both and find the frequency of above as well. If k is greater than or equal to above frequency, then GCD will be 2 into present, because we saw in the previous example. So what is the answer? It will be simply length into 2 into previous value, because the new GCD is twice GCD. Because if k is greater than or equal to above, we can multiply all the least frequency values. So the maximum answer is 2 into that value. Else the GCD is present itself, because we have already computed present. If k is less than the maximum frequency, we cannot change, and GCD is present itself. So answer is equal to max of length into present. One mistake that we can try to do is don't update previous is present is equal to 2 into present if k is greater than frequency. Because if this is the case, if k is greater than or equal to above, then GCD is equal to 2 into present. Because present is GCD, so we can blindly do present is equal to 2 into present. But that is not correct. Why? Because for I to j, it is the present GCD. And this is correct only for this one. But if you are trying to go for the next one, the 2 power minimum can be reduced. For example, the minimum 2 power in the Subarray ij is 2 power 2. But this value can be 2 power 1. So obviously the whole configuration can change when traveling from I to j, I and j to I to j plus 1. So don't try to update present. So just present is normal GCD. Don't double even if k is greater than frequency. Just double in the answer while finding answer. So let's check the code. TP of n is equal to maximum 2 power value, and we are traversing everyone, and we are traversing till 2 power is equal to 0. Not that is till odd, we are dividing by 2 and incrementing the answer, and answer is equal to 0. And we are traversing every starting point of Subarray, and present is equal to present GCD. And what is the minimum power? The values are given less than 10 power 9. It is maximum 32. So let's assume that minimum is 35, so that we will update with the first value itself. So minimum is 35 and the count of minimum is 0. And we are starting for the I to j, which is the end point of the Subarray, starting at I. So we are updating present, and if the 2 power j is less than minimum, so we found the new minimum, because the minimum is minimum till now, and we found TP of j less than till minimum. So the new minimum is updated, it will be TP of j. As this is updated, the new minimum is only 1, which is the present value. So count minimum is equal to 1. If TP of j is equal to minimum, it means that the old minimum is 3 and the 2 power present is also 2 power 3. So obviously the count is increased. Because this is the least frequency, so increase the count. So increase count, and length is equal to j minus j plus 1. If k greater than or equal to count min, it means that we can double every value which is least 2 power possible. So answer is equal to into 2. Else answer is equal to just into 1. Finally return the answer. In this way we can do the sum. If you have any doubts, comment below. See you in the next video.